All right, so question 1D says a train passes a signal at a velocity of 40 meters per second. So I'm going to do this again on a separate sheet of paper. This is 1D, part 1. So we've got train passes a signal. Here's my signal. I was going to draw an old-fashioned sort of signal. Here we go. Usually have like a circle on them as well, like a red or a green or whatever it is, which lights up. And it's traveling past here, and the velocity at this point is 40 meters per second. We also know the acceleration at this point as well. Acceleration is equal to 16 minus 2t. Now, the acceleration is actually quite a useful thing to know, because if we wanted to find a formula for the velocity, well, velocity, of course, is going to be the integral of acceleration with respect to time, which, of course, is equal to this thing here plus c. And c is the constant already happening. So the velocity is equal to 16 plus 2t plus 40, where I'm increasing the power of t by 1, dividing by the new power, increasing the power of t by 1 and dividing by the new power, and adding on the c value at the end. Now, there's a reason why we don't need to do this, and I'll show you, but it's going to be 16t plus, minus. This is a minus. What am I doing? I should have a minus in there, not a plus. Because it's a minus. Here we are, it's a minus. Minus t2 onto a 2 is going to be t squared plus 40. So if I went ahead and I said, well, we want to find where this is a maximum. In other words, this thing here is going to look something like, and I'm just going to spitball here and kind of try and draw it. In fact, I've got no idea how it's going to look. It's probably something like this, though. It's probably going to be like this. And we're not really interested in these 2 points here. What we're interested in is the maximum here. So the maximum there is going to be the differential of this. And we already know the differential of this. It's there, yeah? Because we started, that's how we started. So we're going to use the differential, which just happens to be called acceleration. So if we make acceleration equal to 0, which is the differential of this thing here, so in other words, the dv dt, which we don't have to write, is equal to this thing here, which is 16 minus 2t. Now, if we make that equal to 0, we're going to find where m is 0 at the top here. In other words, we're going to find where this is going to be a maximum, yeah? And we would find how high this goes here, yeah? So the height of this is going to be, m is 0 there, but the height is going to be the velocity. So this is along here, this is time along here, and this is velocity along here. And this, of course, would be the maximum velocity. All right, so this will be the time when it's at the maximum velocity. This would just be the value of the maximum velocity. So what would that be? So in order to do that, we want to find out what that time there is. What is the time when the velocity is at a maximum? So let's go ahead and do that. So it's going to be 16 minus 2t, which means that 2t must equal 16. Divide both sides by 2, and t equals 8. And that's going to be 8 seconds. So we found the time when this is at a maximum. So the t here, t there happens to equal 8. Now, if we put that back into the original equation, which is, when I say the original, I mean the equation for velocity, there it is. We put that back into the equation for velocity, we're going to find the velocity at that point. So let's go ahead and do that. So therefore we could say velocity, I'm going to put maximum here, is equal to 16 times 8 minus 8 squared plus 40 is equal to, and I'm going to just throw all that straight into the calculator and see where we end up. It's going to be 16, here we go, 16 times 8 minus, and I'm going to put an 8 squared here, plus 40. And we get 104. So velocity, the maximum velocity, is going to be 104. And now I'm assuming this is going to be meters per second. so meters per second, so it's going to be meters per second. And that's the velocity that we should probably end up with. So that's how I would do that. We didn't need to differentiate it to get back to where we started. We could have just said, well, velocity is at a maximum when acceleration is 0. Yeah. So you could say here, velocity is a maximum when acceleration is equal to 0. And that's why this thing here works. But otherwise, yes, you could. You could find velocity, you could differentiate it, which is getting back to where you started, make it equal to 0 and solve for t to find the time when velocity was 0. And that's how you would probably do this.